8.1, confidence intervals. Confidence intervals. Confidence intervals are a interval that's saying that we are confident within a certain percentage that the actual mean or proportion of a population is within a certain interval, okay? So again, you have a population, you're gonna take a survey, right? You're gonna do a simple random survey here, right? And you're gonna have, let's say that we get a proportion here of P, which means that here we're gonna have the P hat, right? This is the estimator, right? This is the estimator, okay? So and we also discussed that P hat is the same as P because it is an unbiased estimator, right? So we will use the estimator and within our confidence interval, because our confidence interval is going to look like this. This plus or minus is something here, okay? This is the interval that we're going to talk about, all right? So within that interval, we will use the estimator here, or what we call the point estimate. The point estimator, okay, all right? So if you go to page 495, there's a green box there that says, a point estimator is a statistic, because this is the population, this is the sample, so this is a statistic, right? The statistic that provides an estimate of a population parameter, right? Because this was a parameter, this was the statistic, right? Okay. The value of that statistic from a sample is called the point estimate. So this is the point estimate, okay? So that example there is really, okay. So let's go ahead and look at the example there from batteries to smoking. Identify the point estimator you would use to estimate the parameter in each of the following settings and calculate the value of that point estimate. So A, quality control inspectors want to estimate the mean life, mu, of the AA batteries produced each hour at a factory. They select a random sample of 50 batteries during each hour of production and then drain them under conditions that mimic normal use. Here are the lifetimes and hours of the batteries from one such sample, okay? And it gives you the 50 lifespans, right? So how would you find the point estimate here? How would you find the point estimate? Well, it's pretty simple, right? You just add them together and divide them by 50, right? Nothing really magical going on there, right? B, what proportion P of US adults would classify themselves as vegan or vegetarian? The Pew Research Center report surveyed 1,473 randomly selected US adults. Of these, 124 said that they were vegan or vegetarian. So again, how would you calculate the point estimate of the producer? So the sample, your sample size was this, and you had this many vegan or vegetarians. So P hat is going to be nothing more than 124 over 1,473, right? 3, the QC inspection of part A, QC inspectors in part A want to investigate the variability in battery lifetimes by estimating the population standard deviation. So you would just calculate the standard deviation of that, right? And how would you do that using your calculator? Eva, how would you calculate that?
You can just put them in the L1 and then do the calculate thing, right?
Right. So you would go put them into L1 and you would do the stat calc. You would do vars 1, right? One variable and one variable statistics, and it'll give you the standard deviation, right? Good. So the idea of a confidence interval, okay? The definition on page 497 says, a confidence interval gives an interval of plausible values for a parameter based on the sample data. Okay, so based on the sample data, it's going to give you so if we have the data, the data looks like this, right? Which we have a p hat here with a certain sigma p hat here, right? It's gonna have a certain sigma p hat. We can say that we are within the interval here, right? No matter what it would be, I don't know what it would be. Depending on what this is, I can say that we are a certain percent confident that the interval from here to here will contain the actual P, right? Okay, the actual P of the population. Okay, so that's what we're talking about when we're talking about a confidence interval, okay? So again, confidence interval gives an interval of plausible values for a parameter based on the sample data. Based on the sample data, p hat, right, it gives you how confident you are that the actual p would be within this interval, right? Now, then we have a confidence level, definition of confidence level. That's on the bottom part of page 497. The confidence level C gives the overall success rate of the method used to calculate the confidence interval. That is, in C% of all possible samples, the interval computed from the sample data will capture the true parameter value, okay? So this is a little confusing. It's a little confusing, okay? So again, what does it say? It says the confidence level C. So if the confidence level is either 90%, 95%, 99%. So these are the confidence intervals that we use, confidence levels that we use, okay? So the confidence level. So the larger the confidence level, what do you think the interval to be? The interval would be smaller or larger? Let's say that again. So I have 90% confidence interval, I have a 95% confidence interval, 99% confidence interval. So in order to capture, to say that I am 99% confident, would I have to have a larger interval or a smaller interval?
Larger.
You'd have to have a large one, right? So you would expect the confidence interval to be larger for a higher confidence level. Okay, all right. So let's flip the page. Okay, so this is the magical phrase that you will always use, and you will use this over and over and over again in this class, okay? Because they're always going to ask you to interpret after you find or calculate a confidence interval. They're going to ask you to interpret that confidence interval within the context of the question, okay? And you will always answer in this way, okay? You'll always say that, this is top of page 498, you'll always reply back that we are 99% confident that the interval from what to what captures whatever it is that you're trying to capture, okay? All right, so we are 90% confident that the interval from whatever it may be, whatever you found, captures the actual whatever you're capturing, okay? So again, those are the magic words that you always have to say, that I will be looking for when you answer in a test. The AP Stats graders will be looking for this phrase all the time, okay? So always you have to answer it, and we are 95% confident that the interval from what to what is going to capture the, average number of siblings of Blanchard Catholic school students, something like that, okay? Margin of error. The margin of error of an estimate describes how far at most we expect the estimate to vary from the true population value. That is, in a C or 90% confidence interval, the distance between the point estimate and the true parameter value would be less than the margin of error of C% in the samples. Okay? All right. So let's go ahead and see if we can do the example here. The example, it says, who will win the election? 2 weeks before a presidential election, a polling organization asked a random sample of registered voters the following question. If the presidential election were held today, would you vote for candidate A or candidate B? Based on this poll, the 95% confidence interval for the population portion who favor candidate A is 0.48 to 0.54. So again, the question they're going to ask you is interpret the confidence interval. So to interpret the confidence interval, again, you follow the rule on the top of page 498 and you answer that. We are 95% confident that the interval between 0.48 to 0.54 captures the true proportion of people that would vote for candidate A. Okay. B, what is the point estimate that it was used to create the interval? Well, the point estimate has to be equidistance between 0.48 and 0.54. So this is a 0.06 difference. So the actual point value must have been 0.51, right? Which is right in between these two. Okay. So you would add these two together and divide it by 2, basically is what you're doing there, right? And so what is the margin of error? So the margin of error obviously must have been plus or minus 0.03, right? Because if you subtract 0.03, you get 0.48. If you add 0.03, you get 0.54. And then C, based on this poll, a political reporter claims that the majority of registered voters favor candidate A. Use the confidence interval to evaluate this claim. Well, you can't say that, right? Why can you not say that? Because in order for the majority to favor candidate A, that means that your interval has to be always greater than 0.5. But unfortunately, it could actually be 0.48, which means that at that point, the majority is not favoring candidate A, they're favoring candidate B, right? So you can't make that claim, right? What does the book say? Because there are plausible values of P less than or equal to 0.5 in the confidence interval, the interval does not give convincing evidence that a majority of the registered voters favor candidate A. Okay, just as you said. Okay. And it looks like we are done here for the first part. Yeah, we are done for the first part. Okay, we'll stop right here. I'll have you start working on the homework.